Good morning, everyone. My name is Sejun Shishan. Today, I will be presenting on the topic applications of vectors in engineering. Vectors are very important in engineering because they help engineers represent quantities that have both magnitude and direction, such as force, velocity, and displacement. In this presentation, I will explain what vectors are and discuss several real-life applications of vectors in engineering. First, what is vector? A vector is a quantity that has both magnitude and direction. It is commonly used in mathematics and physics to represent movement, force, or position because it shows how much and in which direction something acts. From the graph, we can know the object moved 3 units to the right and moved up 4 units. So the vector can be written in 3, 4. Let me share to you some application of vector in engineering field. First is civil engineering. In civil engineering, vector represent forces acting on structures. Engineers resolve force into horizontal and vertical components. This helps engineers to determine whether the structure is stable and safe or not. Civil engineering application. In civil engineering, vectors are widely used in structural analysis to ensure the safety and stability of buildings and bridges. All forces acting on a structure, such as weight, wind load, and support reaction, are represented as vectors because they have both magnitude and direction. Engineers resolve these forces into horizontal and vertical components to determine the resultant force and check whether the structure is in equilibrium. By using vector addition and resolution, engineers can calculate tension and compression force in truss members and beams. This analysis helps prevent structural failure and ensure that the design can safely support expected load. Let me share to you the next application of vector in engineering. Second is mechanical engineering. In mechanical engineering, forces rarely act in straight direction. Engineers use vectors to break force into components. This allows accurate calculation of stress and torque in machine parts. Here is the explanation of mechanical engineering application. In mechanical engineering, vectors are essential in analyzing force acting on machine components such as gear, shaft, and leakage. When a force acts at an angle, it must be resolved into its horizontal and vertical components using trigonometry function. These vector components are used to calculate torque, stress, and overall system stability. Engineers also use vector method to determine the direction and magnitude of resultant force in moving parts. Without vector analysis, it would be impossible to accurately design mechanical systems that operate safely and efficiently. Lastly, the application of vector in roller coaster engineering. In roller coaster design, engineers use vector to model the track in 3D space. They calculate direction vector between points to ensure smooth transition. The angle between track segments must be controlled for safety and comfort. Here is the explanation of roller coaster engineering. Most of the motion that occurs during a roller coaster ride is a reaction to the gravitational pull exerted by the Earth. When the roller coaster train reaches a high point and moves downhill, gravitational force causes it to accelerate. As it gains speed, it has enough kinetic energy to climb the next hill. This process continues repeatedly until the train's energy is gradually reduced due to friction and air resistance. Importantly, the train cannot reach a height greater than its initial peak unless additional energy is supplied. In designing a safe roller coaster, engineers must carefully consider vector force, acceleration, and velocity. Therefore, vectors play a crucial role in roller coaster design. Here is the safety and vector that consideration by roller coaster engineer. Gravitational force vector, normal force vector, acceleration vector, and velocity direction change. These calculations ensure passengers remain safely seated. The train will stay on the track. The g-force remain within safe limit. These vectors are essential in constructing a safe and efficient roller coaster system. Now let me show you the problem-solving question. A roller coaster car moves from point A to -1, 3 to point B, 8, 5, 7, and then continues in the direction of vector v equal to 4i minus 2j plus 6k. Question A. We need to find the vector of AB. 4 marks. AB equal to B minus A equal to 8 minus 2, 5 minus minus 1, 5 minus 3 equal to 6, 6, 4. So the vector of AB is equal to 6i plus 6j plus 4k. The next question is find the magnitude of AB. First, we need to use the equation to find the magnitude. It is AB equal to square root x squared plus y squared plus z squared. This is the formula that can help us to find the magnitude. So it equal to square root 6 squared plus 6 squared plus 4 squared equal to square root 88. The answer is 9.38. Question C. We need to find the unit vector in the direction of AB. Unit vector equal to AB over magnitude equal to 1 over 9.38 times 664 equal to bracket 0.64, 0.64, 0.43 bracket. Here is the last question. We need to find the angle between vector AB and V. First, here is the dot product. AB times V equal to 664 times 4 negative 26 equal to 6 times 4 plus 6 times negative 2 plus 4 times 6 equal to 24 minus 12 plus 24 equal to 36. The magnitude of AB that we find in the question B is equal to 9.38. So we just need to find the magnitude of vector V, which is square root 4 square plus negative 2 square plus 6 square equal to 2 sub 14 equal to 7.48. Then we substitute all the things into the angle formula. We can know that the cos theta equal to 36 over 9.38 times 7.48 equal to 36 over 70.14 equal to 0.513. The theta equal to arc cos times 0.1513. So the theta equal to 59.1 degree. Here is the conclusion about this topic. In conclusion, vectors are fundamental mathematical tools that play an essential role in engineering application. Through the roller coaster car example, we demonstrated how vector can represent direction and displacement in three-dimensional place. By calculating the vector between 2 points, finding its magnitude, determining the angle between vector, and expressing motion using a vector equation, we can clearly describe and analyze movement in space. These vector techniques are not only theoretical concepts but are widely applied in engineering fields such as mechanical and civil engineering. Therefore, understanding vector operation is crucial for solving real-world engineering problems involving motion, force, and spatial design. That's all from me. Thank you for your nice attention.